I will say a few words about Rob. He's one of the contributors of Zen Framework, the main author of the book Zen Framework in Action, main developer for Slim Framework, and I will leave the stage for Rob. Thank you.
I love you people. I've had 2 rounds of applauses, I haven't said a word yet. Okay. I do APIs a lot. I'm not particularly good at websites. I'm aware of websites. I use websites. I can't program them. If you've ever seen a website made by me, it does not look good. I'm very, very good at back-end work. I'm very good at talking to legacy systems and writing APIs. So I want to try to share with you some really interesting things that I think about APIs, the way I think they should be written, the way you should work with them, the way you should build them. And I'm going to do it in the context of Slim Framework because I want to lead developers of Slim Framework. I think it is a really, really good micro framework. And I think you should be using it if you're writing APIs. So this is a bit of a stealth marketing pitch, where I'm going to teach you a little bit about APIs so you write them in Slim, because it's awesome. So let's start with Slim itself. Slim is a micro framework, as I said. It was written by someone called Josh Lockhart, who you may or may not have heard of. Josh has done 2 really, really good things for the PHP community. Number 1, he wrote Slim Framework. That's a really good thing. Number 2, he wrote a website called phptherightway.com. Has everyone been to that website? Yes. If you have not been to phptherightway.com in the last 6 months, you should go and visit it again. It's a wonderful way to learn how to write PHP today, as opposed to how you used to write PHP in 2004. So yeah, awesome. So that's where we're coming from. We've written a micro framework. The whole point of this micro framework is that you add your own functionality to it. There's no ORM, there's no form handler, there's just a router, there is a DI container, and there's an error handler. And that's basically all that Slim is. What's really nice about that is that you can read the source code for Slim Framework in an afternoon. There's no other framework out there where you can read the source code for the framework in less than a week. So try it. Get the Symfony framework and try to read the source code, or Laravel, or Zen Framework. I contribute to Zen Framework. It's very much a kitchen sink framework. It's very, very powerful, but there's an awful lot of code there. Slim is really lightweight. This is a complete Slim application. We always start with hello world. Because this is an API, we're not going to echo hello world out. What we're going to do is we're going to return a response in JSON to a ping request, /ping. If you're going to write an API, this should be the very first method, the very first endpoint that you implement. It is extremely helpful for any of your clients to be able to hit an endpoint on your API that just returns a response. So they can prove that they've got all the bits working together. They've opened up the firewall correctly, they've actually managed to configure Guzzle, whatever they've done. The average client developer needs a very simple endpoint to hit in order to check everything is working. And then they can go and do the complicated stuff. So an endpoint like ping is a really good one. It's a heartbeat endpoint. So that's the Slim framework. It's a store file composer. So we've got the composer auto load line. Then we implement our Slim application, instantiate it, have a $app. Then we write a closure as part of a root, and then we call our grub at the bottom. So the really interesting bit is that bit in the middle where that closure is, that bit there. And I realise I've chosen a really, really poor cut for those things at the top. Sorry about that. Method of the app object is called get. That maps directly to the HTTP method. So we have get, post, push, etc. Then we have the URI pattern. So in this case, /ping, that's which particular URI we want to hit. And then we have a closure or an action or root callable, or a controller. There are so many words for the same basic thing. We'll call it an action. Our action takes a request, it takes a response, it takes some arguments. You do stuff with that, and then you return the response back to Slim, and Slim will send the response back to the client. In this particular case, we just do this with JSON to generate the current time. So every time I hit this endpoint, I'm going to get a different timestamp. This is one really helpful way that I know that everything's working. That number will change. For building the APIs, I highly recommend you learn a command line client. There are two that are worth learning. The first one is called curl. Curl is by far my favorite command line client ever. It is wonderful. It's been going for a long, long while. It's very, very powerful. The other one is called HTTP IE, which is what's shown on this slide here, which is a slightly more friendlier command line client. If you are implementing against an API, if you can find a bug in that API and you want to tell the supplier that there's a problem with their API, if you send them the curl command that shows the problem, they will love you. There is nothing better than a curl command that reproduces an API problem, because then it can be fixed really, really easily. Highly recommend you learn a good command line API client. So we've got something called PSR-7. PSR-7 is the 7th PHP standard recommendation, which comes from a group called the Framework Interoperability Group. You may or may not have heard of the FIG, but you've almost certainly heard of PSR-0 and PSR-4, which are the auto-loading standards that are one of the key reasons why Composer works. So PSR-7 implements and defines how to do HTTP messaging. Everything about the internet, everything about what we do is about HTTP. It is a really good idea if you understand how HTTP works. If you are going to write APIs, if you're going to write websites, if you're going to do anything on the web, understand the fundamentals of the technology that we depend on. We depend on something called HTTP. It is defined by two standards. It's defined by lots of standards, but there's only two you need to read. You need to read RFC 7230 and 7231. They tell you how the internet works at the transport level. That is extremely helpful. Quick proceed. We have a request, we have a response. You send a request to the server sends a response back to you. It's plain text at the PHP level. If you use HTTP 2, it's not quite so plain text under the covers, but from our point of view, it is plain text, which makes it really, really easy to reason about. Request at the top there. First line is called request line. You define the method that you want to execute, get, post, put, etc. The URI, and then you've got the version number of HTTP that you want to use. HTTP 1.1 in this case. To my mind, that's probably not really necessary, because we've gone nearly 20 years and we've only just got to version 2. HTTP 1.1 was around about 18 years before anyone involved we should improve it. That's how long it's been around. After request line, we have a set of key value pairs, which are metadata. We call them headers. These are the key reason why HTTP has lasted so long. It is intrinsically extensible. You define a new header, you can change the out-of-band information, you can make the transport, the applications really powerful without changing underlying protocol. Very helpful. Just key value pairs are all quite easy. There's a code block between them, and then you column separate any values. And then you put your message body. Your message body is a string. It's always a string, just plain characters. Dead easy to understand. Response works the same way, except that we put the version number at the beginning for no apparent reason. Then we have the status code. Everyone knows what status code is. Everyone has seen 404. Everyone has seen 500 internal server error, certainly. So sometimes we even get 200 OK, that's nice. Then we've got our headers and we've got our body again. It's a very reciprocal protocol, very easy to understand. PSR-7 defines an object-oriented interface to the HTTP messaging. So we have a request interface, we have a server request interface for when we're a server, request interface for a client, response interface, and then a URI interface, and finally an upload file interface. Upload files exist because files global, zip global is insane when you've got multiple files being uploaded at the same time. I have no idea who thought that was a good idea. Goodness me. She's looking at us sometimes. It's horrible. It really is horrible. We now get to the one bit of the talk that I want you to not forget. You can forget the rest of the talk. I'm about to tell you two things about PSR-7 that will stand you in really good stead for understanding PSR-7. Key feature one is it's immutable. Immutable means you cannot change it once it has been created. The request, the response, the URI, the uploaded file are immutable. So once the request has been created, it cannot be changed. This is an extremely helpful property for testing, for instance. Once you have an object that you know can't change, it's quite easy to test it, it's quite easy to reason about. It's quite easy to make it work reliably well. That's why we like immutable objects. However, we do need to change immutable objects. Like, for instance, on the line 1 there, I have a URI object that points to the joined in API, list of events. So both I want to filter that list of events by putting a query parameter on, so I only get the upcoming events, the ones that happen in the future. I use the with method. I use with query and create a new object. So URI1 has not changed, but URI2 is a brand new object because they're immutable. This is a very helpful feature. I can then create multiple URI objects with different filters on them, all based off my master object. And I can do the same thing with requests because I might need to add the get method, I'm going to need my URI, I'm going to have to add an accept header, I'm going to need an authorization header. I just use the with methods to do this. So the key feature one is that PSR-7 is immutable. You're thinking, that's an awful lot of instantiations of objects here. In that slide there, I've now got 6 objects. I could have 2 objects, one URI object, one request object. I've got 6, 7 objects, that's a lot of objects. PHP is really, really good at creating objects. It is extremely memory efficient at it, and is extremely fast. That is never ever going to be a performance bottleneck in your application. So I've just saved myself a question for later. Another key feature is the body is a stream, not a string. And the 2 words that can be traced together. But the body is a stream. So PHP stream, not a string. Although the underlying protocol says string over the web, we use streams because it is far more memory efficient for a big file. If you want to upload, I don't know, my clients are all enterprising, so they send me PowerPoint presentations that are 60 megabytes big with 4 slides in them. But if you get the same thing, really, really big files that need to put onto S3. But what I can do is I can send it in as a PSR-7 stream into my request and push it straight out to Amazon S3 using Guzzle, which is also PSR-7, also uses a stream. So I don't need to load the entire file into memory in my PHP application. It just flows straight through. It's extremely memory efficient to do that. So that's why we use streams rather than strings. There's one gotcha. A stream is not immutable. So whilst the rest of PSR-7 is immutable, the streams are not. So be aware of that as well. You can edit them. Okay, that's enough about that. Let's look at our APIs. Specifically, we're going to talk about what makes a good API. Anyone can write bad API. I mean, I'm sure you've seen lots of them. So what makes a good API? What are the things that I think you should be doing to make an API that I am prepared to use? So I'm quite picky now. And realistically, if you've got a bad API and your competitor's got a good API, I'm going with your competitor. And my life's way too short. So what's interesting about what makes a good API? I've come up with a few items we're going to talk about today. HTTP method negotiation, content type handling, honouring the accept header, error handling, versioning are the key things I think you need to be thinking about if you're going to write an API that is worth me using. The first three of those are all about HTTP. They're all about being a good internet citizen. This is really important because the internet is decentralized, and what that means is that when my phone with my app on it talks to the server, it's not a direct connection. There are other computers in the way. We call them proxies, we call them caches, we call them reverse proxies sometimes. Those intermediate computers, intermediate servers, operate via the standards of HTTP. And if you make your API operate by the standards of HTTP, we can cache things properly. We can ensure that we send the right data to the right place. A classic example of where you get this wrong is sending a 200 OK on an error message. Because if you do that, all the proxies between you and that iPhone can cache the response. So when you fix the error, the iPhone doesn't see the fixed error because it's still got the cached error page hit in it. We have systems in place to solve this. It is intentional. Use the right HTTP standards and your life gets much, much better. So we'll start with method negotiation. This is all about verbs, these verbs in particular. There are 5 verbs that we care about. Get, put, delete, post and patch. So if you're using a web browser, you only get 2 verbs. You only get and post. But we're writing APIs, we're expecting our clients to be able to write up to all 5 verbs because we can do far more powerful things as a result. The most important thing to be aware of with verbs is something called idempotency. Is the verb idempotent or not? And what that means is if the verb is idempotent, you can send the same message multiple times and it will not have a side effect after the first time you send it. This is extremely helpful if your internet happens to be unreliable. So if you happen to live in, I don't know, Silicon Valley, you probably don't care. If you happen to live, I don't know, anywhere else in the world, then you probably do care. So what do I mean by this? Right, so you do a GET request. If I do a GET request for a given list of events, I can do it as many times as I like, and nothing changes. That's fine, isn't it? That's idempotent. Suppose I do a post request. So I can post a request to the server. Why do we send a post request? We send a post request because we want to add data. Nearly always, we are adding data via a post request. Sending new data. Traditionally, when you post, say, we use this event, simply post a new event to the server, we get back a representation of the event with the event ID, because there's an auto-increment counter somewhere in the world. So if I send a post request, then I send another post request with the same data, I end up with 2 records on the server. So I send a post request, I don't get acknowledgement, I think it didn't work, but it might have done. If I used a put request, I send the put request, I don't get a response, so I send the put request again, I end up with 1 object on the server, because it's idempotent. I can send that put request 100 times, just to make sure it gets there. But I still only end up with 1 object, 1 new thing on my API, into my server, into my app. That's the power of idempotency. If you're writing a brand new API, and if you can write documentation, because you end up displaying this to all the client developers, use put over post wherever you can. It will make your API more reliable, and you won't end up with double objects for no apparent reason. How do we do this instead? Key things we have to think about is if the method is not recognized, if I try to put onto that ping endpoint, it should fail. If it's going to fail, you send back a 405. In Slim, we have a method called the app object for each of the HTTP verbs. So you just use the right one, and then you put the correct endpoint that you're interested in. So this is a fairly simple CRUD API. List of book authors, so I've got a get and the post on my author collection, and then I've got get, put, patch and delete on my author representation, each individual representation themselves. If you have an endpoint that you want to respond to more than one method, then you have a couple of helpful functions. We've got any, so it will respond to absolutely any basically method. Well, we've got map, where you can give it a list of the verbs that you actually care about. So the very last line there, we care about get and post, it's in /author. That can be more helpful if you're writing websites with a form or something like that. You tend to see that in use. That race ID is not a literal string, it is a placeholder. So race ID is a placeholder, it represents any number you like or any random string which then appears available to you in your action. So in this case, we're getting out the arguments parameter, which is a third parameter to our action, grab the ID, and then we can do stuff with it. That placeholder is simply regular expressions. So here likes regular expressions. We need more hands. Everyone should like regular expressions. They are great. They're quite difficult to write. Regex101.com solves all your problems. So what you do with your regular expressions, you've got a colon after your placeholder name, so ID colon, and then you put a regular expression which is a constraint. So here I've got /d plus, which means it must be a number and there must be at least one character, or one digit. Or I could do something more clever. I could do year, month. Year must be 4 digits and month must be 2 digits, as in the last example on that slide. So I can constrain the parameters to being the values I want to be, and Slim will not match unless you have the correct regular expression. Your data matches the regular expression. Quite a bit of power there. It shows you getting data into your action, the type you like, the type you want, and also enables you to be selective against the same endpoint. That's method negotiation. Content type handling. Content type header is all about the data coming into your application. So if you send me some data and it's JSON, you send the content type header of application JSON. If you're going to send me plain text, then you send me the content type of text/plain. This is the way we know what the data means. APIs in particular care a lot about this. We don't try to infer it. Browsers are particularly exploitative. Browsers will take a guess of what type of data it might possibly be and do their best to render it for you, because that's what the consumer expects. An API does not do that. An API trusts the header. So you must send the right header, and given that you've got the header, you can then decode the body correctly. We have a method called getBody. So on our request object, you call getBody, and now you have the body. And if we go to Vault object or something like that, print on in this case, you'll notice it is just a plain string. So now you're going to have JSON decoded or whatever. As you can imagine, it's really, really common to want to decode application JSON. We want to do it all the time. All APIs, structured data, we always have to decode it, we want it as an array. So built into the system, built into PSR-7 in fact, is a method called getParsedBody. When you call getParsedBody, if Slim understands the content type, it will decode it for you and give you an array back. So in this case, I get back an array with one element, which is Terry Pratchett's name. That just works. Nothing to do out of the box. As long as your client says, all right, it's content type, Slim will give you the array decoded automatically for you. Slim will also do this with XML for you. It will also do it with form data for you. Out of the box, you don't have to worry about any of that. The data comes from your client, we will decode it for you. What about if it's something slightly more esoteric? That CSV format. Suppose we have an API that allows us to upload a CSV string so we can do multiple data records simultaneously, for instance. So here's an example. You may imagine an authors.csv, it's got two columns, author's name and the date of birth. We can imagine uploading it into our API. How do we handle that in Slim to automatically decode it? We use something called the media type parser. So what we do here, on the request, we can register a media type parser against a particular content type. So if you look at line 2, I'm saying that if it is text CSV, then please run the closure that starts on line 3 through to about line 13 or so. So this closure will be executed only if the data is of text CSV type. So that comes back to why we care about content type. The closure doesn't really matter what it does in this case. It does the right thing, trust me, I tested it. You must return the parsed data as an array. So you get given a string, you return an array, and you have done the work for converting this particular media type, and then the rest of your application just works regardless. The very powerful thing about this is we have separated out the decoding of the input data from the processing of the input data. The two are now nicely decoupled, which is really helpful. You get an output of something like that. Okay, just like segue now, because we want to run this, every single request that comes in, we need to register our media type parser. How are we going to do that? And the way we do that is something called middleware. So this is a quote from a friend of mine, Matthew Garofoli. Middleware is code that exists between the request and the response, which can take the incoming request, perform some action on it, and then either complete the response or delegate onto the next middleware in the queue. So what we've got here is a concept of adding a stream of data or a pipeline of data operations to our request and our response cycle. It's quite a powerful way of doing things. So in this example here, we have some authorization middleware. So the request comes from the client, it hits our authorization middleware, and maybe we check for the authorization header. If it doesn't exist, then no go. You're not allowed into my API unless you have an authorization header. So that middleware can return a response, and the rest of the application doesn't have to run. That's really, really helpful because it's much more efficient. Makes it much quicker. We get lots of stuff done. We turn off and throw away this request as quickly as we possibly can. If it is successful, we might get to validation middleware. This middleware might validate the data, decide whether it's acceptable or not, before it finally hits our app. The app will create a response, return it, and that goes back through our middleware chain. So this gives us a lot of flexibility at the HTTP message level to control what actually enters into our application itself. Code-wise, it's just a closure. Not particularly complicated. You take 3 parameters into your closure, a request, a response, and a next callable, and you must return a response. This is a common thing in Slim. If you're writing a closure, you almost certainly have to return a response if it's related to the HTTP pipeline. When you're in your middleware, you can do something with the request, then you call next, which is a callable, which will call the next one in the chain. Next will always return a response, which you can manipulate, and then you return back to the client, or further back up the chain, literally. Very, very simple pattern, which means it's very easy to understand. And much more importantly, it's trivial to debug. And we care about that. Debugging's horrible. It's pain, it's difficult. If you can have code that we understand, it is far harder for a bug to hide in it. So we have that media type that we need to register every time. One way we can do that is to implement it as middleware. So every time the middleware runs, we register our media type parser so that we can decode text CSV. That's one use of middleware. A handy way to do things. Let's go on to types. What's next? Accept headers. Accept headers go the other way. So we've taken data into our application. We've looked at the content type header, so we know how to decode the data. The other way is the accept header. The accept header is a client telling you the format that it can understand. So in this particular example, we can accept application JSON. So if you go and send it XML, you have broken the contract. If you don't send it HTML, then I'll get very angry. You do not send data that the client cannot understand, because the client has told you what data it can understand. It's just rude. Do better. Built into Slim, there's a method called with JSON on the response object, so sending back JSON is trivial, because it turns out that we all do it a lot. It's by far the current lingua franca of APIs. So given your data array, response with JSON, you'll get the JSON formatted data with the correct header in the response object going back to the application. Notice you should also set the status code at the same time, because it turns out that these two go together quite a lot. So in this particular case, I've set the 201 status code because I've created an object, or created a resource, or API. All quite easy. Pretty JSON. XML, have to do it ourselves. It turns out that given a PHP array and generating some XML is not quite as trivial as doing JSON. There's more than one way to do it. Do you make the sub-elements in the array sub-tags? Do you make them attributes? There's more than one way to describe a PHP array in XML, so you have to do it yourself. Or you then download a library from Composer, which is how the rest of us do it. From our point of view, the interesting thing is that we need to detect that the client wants XML instead of wanting JSON or whatever formatted ones. And we do that using Will Durant's negotiation components. Grab it from Composer because it is really, really good. It's quite simple to use. You give it a list of known application types that you understand. So that's line 5 on that slide. And then you pass it into a method called getBest. And given the accept header, given the list of media types that I understand, negotiator will tell me which one I should be using. And that's it. It's quite easy. To actually do the formatting itself, you simply switch on that media type and generate the relevant response. If you don't know, or you cannot create the format that the client tells you that it wants, send back a 406. There's no point in sending it JSON if you can't accept it. Waste of time. Send back a 406 so the client developer can fix it properly. Get data like that. We've got the error handling. API error handling is the most important thing you can do when writing an API. It cuts down the amount of support calls you get. I don't know about you, but I don't like receiving email. I particularly don't like receiving email because I have to tell someone how to use my API when I could have let the API tell them how to use it themselves. Write good error messages because it saves you the hassle. It saves you a lot of hassle. As a client developer, I implement and integrate against a lot of APIs. And it's one of those features where if you have poor error handling, I'm unlikely to want to recommend your API to anyone else. The APIs that we recommend as developers to other people all have great error handling. That is not a coincidence. It's because they're a pain to develop against an API that doesn't have good error handling. So make sure you have good error handling. In Slim, we have this in 3 different ways. We have the method not allowed that we've already talked about. We have the concept of a not found error handler, and then we have the concept of a generic error handler. It's important you handle all 3. Method not allowed we've already covered. It will happen automatically for you. You don't have to do a thing. It will always send right 405. And we will send a message back to the user too. So in this particular case, you will notice that I did not send an accept header. So Slim has to take a guess at what you mean. And Slim has guessed you meant HTML because Internet Explorer is stupid. Fundamentally, Internet Explorer, I don't know if it does now, Edge might do, but certainly the older IEs did not send an accept header that said that it understood HTML. Arguably, it didn't. But clearly, if I'm writing a website, I would quite like it to work in IE. That is certainly what's a fairly sizable percentage of the people with credit cards that I wanted to hit. So that's why it's HTML. And it's nicely formatted, not very well styled because I don't do websites. If you send an accept header, Slim will automatically put it in the right format for you. So although we won't automatically parse XML, we will send XML back if we can. Because we can generate XML for you. And we'll do it for JSON as well, because that's not a common one. If you want to do not found yourself, there is something called the not found handler. So the really common case, that one there, not standard not found handler, if you hit an endpoint that doesn't exist, then it's going to return not found because the router can't find the URL, and that's quite simple. It's quite common that there are other scenarios where you want to send back a not found. The most common one is someone's tried to retrieve some data at a particular resource endpoint, and that data doesn't exist. The ID is not in the database. So for doing that one, you can call this not found handler, and it will raise the correct not found response for you, so you can simply return it, and it will be formatted correctly appropriate to the header, the accept header and everything for you. So returning a not found because you can't find the data in the database is a single line of code. So there's no excuse for making it complicated, you don't have to. Most of the errors in Slim are generic errors, and these occur when you throw an exception. If you throw an exception, Slim will generate you an error. So here's the example. Here I've called the /error endpoint, it threw an exception, I got this error message. You'll notice that there's not a lot of information about what went wrong. The entire error message is Slim application error. That's not particularly helpful to you as a developer, but also it doesn't leak any bad information to an attacker. The error or the exceptions information is in your error log. We put it there for you automatically. We discovered that there is a sizable percentage of PHP developers who have got no idea what the error log is. I'm going to assume that none of those are in this room. So don't raise your hand if you don't know, because then you don't embarrass yourself. Know what the error log is. It is really, really good. It was built into PHP for a reason. That if you would rather interactively see the error message, we created a setting for you called display error details. If you set that to true, and never ever do that in production, then you'll get the full stack trace in your error response. So you can actually go and find out what went wrong. In my experience, 9 times out of 10, a password ends up in here. I have no idea how that happens, but if you ever turn this on in production, the very first error trace that goes out will have a password in it. I have no idea why that works that way. Every single time. But this makes life really easy. Again, it is in the format that you said on the accept header. So if you're writing a normal website with Slim, you'll get a pretty HTML page. And we let someone else style it, so it looks okay. If it's an API like I deal with, then we generate JSON or we generate XML as appropriate. Top tip, you can use the same handling for warnings. It's quite easy to ignore warnings. Don't. Warnings exist in PHP for a reason. I recommend turning them to errors unless you know why you don't want to. The quickest and easiest way to turn a warning into an exception is to register an error handler that does it for you. It's only a few lines of code. The silent handler, you know that sign that you're not supposed to ever use? That sets the level to 0, so you can actually turn it off. But then if you throw an error exception, then the rest of the Sim's error handling will kick in, and life will be fine, and you will actually catch the warnings, and you will fix those warnings, and upgrading to PHP 7.1 will be much easier. Because we're all 7, aren't we? Very close. Very soon, any day now. Last thing I want to cover, versioning. There's a school of thought that says you should never ever version your API. I nearly subscribe to that school of thought. In the ideal world, I 100% agree with it. In the real world, I'm not that good. I would love to be so good that I could design an API that never ever needs a BC break. You only ever need to increment a version number if you make a backwards compatible break. You can always add to an API. You can always add to an API response. So you can add new methods, you can add new endpoints, you can add new data to the response representations without changing the version. If you can avoid changing the version of your API, do it. The minute you have 2 versions of your API, you have 3 times as much work. The minute you end up with a 3rd version of your API, you have 7 times as much work. It fills that sort of level of complexity. It gets very, very difficult to manage and not screw things up. So be very, very careful when you introduce a new version into your API and avoid it if you possibly can. Add a new endpoint. It's a better solution than trying to change a current one. So now I've told you that, you're all going to go away and promptly make a new version of your API because that's the way these things work. If you're going to do that, you need to tell the clients, or the clients need to tell you which version of the API they want to use. And there are 2 traditional ways of doing this. Firstly, you can do it within the URL. So we can put /v1 or /v2 inside the URL. Just put it straight into string. Very easy to use, very easy for developers to understand. And then the other way is to use a media type. So the media type is the accept header. We can create a custom media type. So here I've used application/bnd.rka, which is my initials, author.v1 plus JSON. So the plus JSON is a format, v1 is a version of the API. Some people think that's slightly more pure because the author record is to be at the same endpoint regardless which version of the representation of the author is being displayed or being rendered. I don't really care. Whichever one feels better to you doesn't really matter to me. If you're going to use URL for your version numbers, then the easiest way to do that in Slim is to create a group. So you just wrap all your routes that you've created, all your actions, put the whole thing in a group and put /v1 in there. And what the group does is it prepends the URI of the group to all the other URIs. So every single one of the URIs I put within this group are now part of version 1 API. So quite easy to do. If you're going to do this, I highly recommend you use separate source files. That's the other thing about versioning. try to switch within the same source file, sooner or later you'll screw it up. But use separate source files. To do the media type one, I'm going to do a quick segue into what dependency injection in Slim looks like, because it makes life a little bit easier for this problem. Slim uses pinballs. Everyone heard of pinballs, do I? Few people. It's written by the Symphony people. It's a really, really simple VI container. You can read it in about an hour and a half. The entire source code of this VI container is maybe 150 lines long. It's really, really simple, very easy to understand. The whole point of the VI container is that we can define dependencies for a given class separately from when we use them. So here inside this particular file, I'm generating two different registrations in my VI container. And the way we look at Pimple is we use array access. So one is called PDO on line 4, and one is called author mapper on line 8. And then it's just a simple callable which specifies how to instantiate an object. We call them factories because it sounds cool, but practically it's just a file function. Just return a new object from a factory, or from a function you have a factory. That's all a VI container does. They're not particularly complicated things. The nice thing about them is that we don't instantiate the objects unless we need to use them. So here I've got author mapper, for instance. If I'm calling an endpoint like ping, I don't need an author mapper. So the VI container won't call this function, hence it will not instantiate my author mapper, which means it won't instantiate my PDO object, which means I won't connect to the database because I don't need to. So the really nice thing about VI containers is that they cut down the amount of resources you use, both in terms of memory and in terms of things like database handles or file handles. That's their biggest benefit. The second biggest benefit is that it makes testing so much easier. In Slim, we can then use this to create controller classes. So rather than writing a callable, a closure rather, for our action, we can write a class. So here I've got a class called author controller, which is now registered to my container. So I've created a factory on lines 1 through 5. All it does is instantiate a controller, and then I register it with my root by putting the name of the controller, followed by a colon, followed by the name of the method, the action method within that controller that I want to run. And then Slim will calls the VI container to instantiate that controller if it needs it. If it doesn't need it, it won't get instantiated. Author controller is trivial to write. You'll notice that signature is exactly the same as what we have for the callables. Request response arguments must return a response. So I've got two media type versioning. The reason this is interesting for media type versioning is that we can have two different controllers for the different versions of our API. And we can select which particular version of the controller we need by inspecting the request object and in the contains factory function returning the correct instantiation. So now I've completely separated version 1's controller from version 2's controller, and my DI container simply registers instantiates the right one, which means that the registration of the URL doesn't change between versions. So I don't have to change everything in my router to have different versions of a controller, which means that I can do it piecemeal. It can be quite helpful. And that's all I want to tell you today. Key things. Good API deals with HTTP properly. If you're going to write an API that you wouldn't need to use, you're going to deal with HTTP properly. You're going to use verbs. You're going to understand what hyperpotency means. You're going to use content type handling. You're going to listen to me when I send an accept header. You're going to write some error handling so that when I do screw up, I will understand how I screwed up and I can fix it. That's what error handling is for. Help the consumer fix their problem. And then you'll version your API in a way that it will work nice and smoothly, and you won't create coupling between version 1 and version 2 of your API. Slim is a great microframework for doing all this. It provides HTTP routing with URLs and method matching. It's PSR-7 compliant, which means that it works really well with other PSR-7 components, like Guzzle, for doing connections to S3 or something like that. Built-in dependency injection, which results in faster applications using less resources that are easier to test. And it's got built-in error handling so that you will be able to implement that fairly easily. If you want to know a bit more, then there's some useful URLs. You don't need to photograph it because the slides are up on acrobat.com anyway. PHP.com I've talked about, make sure you go and visit it. Slimframework.com is the main website. That's where you'll find everything you need to know about Slim. And then I've written about it on my personal blog, so acrobat.com. If you want to see a whole application and sort of poke around in that application, then on my GitHub there's an application called Slim Bookshelf API, which is a fully fledged, well-rounded API that will show you all of these things. That's it. Has anyone got any questions? I'm still thinking about questions and people are getting mics around. If you found anything useful in this talk, I would really appreciate it if you could rate me or provide some feedback on the joined in. The organisers would love to know whether I've done a good job or not. I would like to know that. If there's anything that made no sense whatsoever, I want to know that too. So tell me what you found useful, what you found not useful. Okay, question?
Yeah, hi. Regarding first instance of your writing style and presentation style, my question is regarding maybe the comparison between Slim and the other micro-frameworks like Lumen.
Right, comparison between Slim and Lumen and Silex and Expressive. I'm not a very good evangelist. I don't really care. I have a few opinions. I don't think you should use Lumen because I don't think it is a key focus for the Laravel people. I think they focus more on their full stack framework than they do on Lumen. And they certainly have retargeted it since they've released it. So I think if I was in that sort of community, I would write a pure Laravel application rather than use Lumen. I don't know anything about Silex other than it's not PSR-7, and I think it's not wise to not use PSR-7 for certainly in the microframework world, but certainly for an API, because the ability to plug in other people's middleware is really, really helpful. But I think I'll be a bit careful about using Silex nowadays because they don't support PSR-7, at least not natively. Expressive is a really, really good framework. It comes from Zen Framework. I've been a Zen Framework contributor now since 2006, so I like the Zen Framework community. Expressive is a very nice framework. It is more, what's the word I'm looking for? Correct, maybe. Maybe it's more theoretical in some ways than Slim. Slim is a very pragmatic framework. We've written it very much to be easy to read, easy to write, easy to build on and get going on. Expressive is slightly more complicated in that sense because it thinks at a slightly higher abstraction. But that's not to ding it at all because it's really, really good at what it does. Realistically, if you use Expressive or using Slim, they're both equally good. Anyone else?
Sorry to have
Oh, no more questions.
With lots of breaks, sorry, because next speaker is waiting. We have to strictly respect the schedule. So
that's it. Thank you very much.